Intelligent Transportation Systems Podcast. Welcome to the ITSPodcast. This is episode 6 for October 2013. I'm Javier Sanchez Medina from the Intelligent Transportation Systems Society. We have cooked a tasty new episode for our listeners, where the main course will be the interview done to Professor Vincenzo Punzo on simulation and modeling for ITS. We also have astonishing news regarding the collaboration of the Karlsruhe Technical University and Daimler. A fantastic new autonomous driving history page was recently written in southern Germany. Finally, we also have a transportation in history mini section where you'll hear about the unexpected history of NASCAR motorsport. So let's get to it, have a seat, relax and enjoy.
This is the news mini section for October 2013. Another exciting milestone has been reached to the history of intelligent transportation systems. The Bertha-Benz commemorative route is a well-known route in Germany, chosen 125 years ago by Bertha-Benz for the first historical long-distance drive in a car in 1888. It is a 100 kilometers long route on federal and state roads from Mannheim to Pforzheim. This route includes several larger German cities as well as numerous villages with narrow passages, cross-country roads, and lots of challenging traffic. It has been recently published that the Daimler Research and Development Department has realized a car based on a Mercedes-Benz S-Class, with the scientific support of the Research Center for Information Technology at the Karlsruhe Institute of Technology, which followed the historical route, running automatically with close-to-series camera and radar sensors. We are arranging an interview for a future ITS podcast episode with someone from Daimler and someone from KIT. So stay tuned because you don't want to miss this. Visit this podcast site for links and pictures regarding this history-making accomplishment.
Transportation in history. What has in common prohibition and motorsport? NASCAR. The National Association for Stock Car Auto Racing is a family-owned business that includes, among others, the Sprint Cup Series, the Nationwide Series, and the Camping World Track Series. Its origins are very peculiar. The legend says it all started because of the dry law. Apparently, the Great Poverty from Virginia on down to Georgia at the beginning of the 20th century left illegal whiskey business in a very attractive position. So the story is that young drivers fill up their small fast cars in the Appalachian region of the United States and then rush to distribute that illegal drinks to the rest of the country. So in order to evade the police, they had to have faster cars than the authorities, even with their trunks filled up with whiskey. The dry law was abolished in 1933, so that business became useless, but apparently that young population had the eager for speed there to stay. They continued racing, improving street cars, making them lighter and stronger. There's a parallel story that sums up to the bootlegging legend. In the 1920s and the 1930s, Daytona Beach was the most famous place in the world for pursuing land speed records. After a legendary race between Ransom Olds and Alexander Winton in 1903, that beach became iconic for motorsport fans and 15 world records were set on what became the Daytona Beach Road Course between 1905 and 1935. These grew bigger and bigger across years until NASCAR was founded by William France on February 21, 1948. Contemporarily, on the other shore of the Atlantic in Europe, some appoint 1947 for the start of another ancient motorsport, Formula One. But this is a different story with bootlegging out of the picture. Well, we're now to start with our today's interview. We hope you enjoy this. Hello, we're today with Professor Vincenzo Punzo. He is visiting scientist as senior researcher at the European Commission Joint Research Center in Ispra, Italy. He is currently on temporary leave from the University of Naples, where he is assistant professor. He is also member of the Transportation Research Board's Traffic Flow Theory Committee. His scientific interests range from modeling and simulation of road and rail transportation systems to driving simulation and road safety. Hello, Professor Punzo. Can you please introduce yourself to our listeners?
Sure. Good morning, Professor Medina. First, let me thank you so much for inviting me to this episode and for your nice introduction. Concerning my background, I received a PhD in Transportation Engineering at the University of Naples, Federico II, in 2001. Then I got a postdoctoral grant on traffic microsimulation at the same university, where I became assistant professor in 2005. Currently, I teach there a course on traffic simulation and control. And 2 years ago, I joined the European Commission Joint Research Center as visiting scientist, as you said, with a senior research grant. As for my research activities, since my PhD, I spent time researching the field of traffic modeling simulation mainly, also investigating issues such as the integration of traffic and driving simulation and the pollutant emission models. In the last 2 years at GRC, my work was also focused on ITS and e-mobility.
Very interesting. Professor, you have recently received the 2012 TRB's Green Shields Prize for, and I'm quoting, basing sound theory on rigorous empirical analysis because of your paper titled Can Results of Car Following Model Calibration Based on Trajectory Data Be Trusted? Congratulations on that work, Professor. Can you tell us what was it about? It seems like a provocative title.
Yes, thank you. It is a provocative title. As it suggests, the work puts into question the reliability of results by the calibration of microscopic traffic flow models. And I would go a bit into technical detail, maybe to explain you the content of the paper. In fact, though calibration of such models is recognized as necessary for any real application, at the moment there is no established procedure in the field of literature. And if we focus, for example, on car following models, we will find many scientific works dealing with the calibration against disaggregate data, that is, real-world vehicle trajectories. But let me say there are at least two orders of problems with these works. First, when you calibrate a model against real data, it is difficult to grasp something about the quality of the solution found, whether it's global or local, for instance, especially when dealing with nonlinear and smooth response surfaces, as in the case of microscopic traffic flow models. And this also means that it is difficult to know whether the algorithm or the optimization setting adopted are really effective for the problem at hand. Of course, this problem not only arises in the calibration of traffic simulation models, but in general affects the wider class of black box optimization. And the second problem I see in this work is that all they adopt different data sources with different and not quantified errors and different optimization settings that make, of course, results not really comparable with each other, and also explain to some extent some contradictory results existing in the field of literature. So in this work, we basically propose a methodology to verify a calibration setting. This methodology is based on experiments with laboratory data, and using such methodology, we analyzed all the calibration settings applied so far in the field of literature, and we uncovered some nice results. So I invite you to read the paper.
Will do. Professor, you are pretty active internationally. For example, I think you are the leader researcher for that cost action called Multitude. We have many listeners from outside of Europe, so I think we need to explain what's a cost action. Could you please?
Sure. COST is the acronym for European Cooperation in Science and Technology, and it is an intergovernmental framework that allows the coordination of nationally funded research on a European level. In other words, COST does not fund research itself, and this is a problem, but provides a platform for European scientists to cooperate on particular topics. Topics that, of course, for relevance and complexity, need the coordination of nationally funded efforts. And these projects are just called actions.
And reading the action name, I guess you were numerous in it. Is that so? How many researchers were involved? How many countries?
Yes, Multitude at the moment involves 17 countries, and in the last 4 years, around 100 researchers.
Wow.
Though, of course, with an homogeneous level of involvement, but let's say 100 researchers took part to its activities in some way.
And can you tell us which is the motivation behind Multitude, and what did it aim at?
Yes, let me say that over the last decade, the simulation models have become an important tool in transportation science and engineering. However, there is a raising concern about the true applicability of such models to real-world problems, such, for example, the evaluation of ITS measures. And this is, of course, restricting the use of the model and the true exploitation of their capabilities. And the main concern, indeed, is on the trustworthiness of results from such complex model. Concern that, of course, is shared with many other disciplines where complex natural or human systems are modeled. And to this regard, I would like to quote Hornberger and Speer, who well explain this concern. They say, most simulation models will be complex with many parameters, state variables, and nonlinear relations. Under the best circumstances, such models have many degrees of freedom and with judicious fiddling can be made to produce virtually any desired behavior, often with both plausible structure and parameter values. So I think that I like very much this sentence because I think it explains very well both the sides of the same coin. Let's say, on one hand, raising difficulty tackled by modelers in the current simulation practice, and on the other, the risk of an instrumental use of modeling. So, the concept of Multitude project came out from this frame, and I can read you basically the three main objectives of the Multitude project that were first to develop methods and tools to help users apply available traffic simulation models correctly, effectively, and repeatably. Second, to promote the culture of the management of the uncertainty and the quantitative validation of models and simulation tools. And third, this is the most pleasant part, to provide training for end users in setting up traffic simulation studies. So these are really the main objectives of the action.
I see. And why, can you tell us, why is this important to ITS?
Well, traffic flow models clearly have a crucial role in the evaluation of ITS impact. And they are critical both for the phase of development and prototyping of ITS applications, but also for their full-scale deployment. So we need them to understand the value and effectiveness of ITS, but also the level of accordance to policy goals. and I get acquainted with this, especially during my stay at JRC. And for example, to give an example, in the 2010 European Directive on ITS, it is stated that ITS will make a significant contribution to improving environmental performance, efficiency, safety, and so on. And this is, of course, generally acknowledged also in our transportation community. However, this contribution is not really quantified elsewhere. And for example, it's not completely clear to which extent ITS are likely to contribute to achieve the very ambitious objectives set in the European Transport White Paper. And so it is clear models are crucial in this process. And we, of course, we need to work in order to increase the trustworthiness of these of the results of the simulation tools, and of course also to increase the transparency of the decisions made upon these models. Because here the problem is, as I was saying before, the risk, of course, is the instrumental use of these models.
And what scientific goals has this action yielded in terms of new models validated or applied? We would need concrete examples to engage our listeners. Can you tell us some examples?
Yes, sure. So thank you to inviting me to this question. Well,
sure.
First ambition goal was that of transferring the knowledge and the techniques for the management of uncertainty in simulation to the traffic modeling community. Such techniques, indeed, I refer in particular to techniques for global sensitivity analysis and uncertainty quantification, are becoming part of a rising transversal discipline in simulation modeling. And in this, we were very lucky to be able to collaborate with people from one of the leading group in the field, that is the group of Andrea Saltelli at the European Commission Joint Research Center here in Ispra. And so we applied this global sensitivity analysis, such as variance-based techniques, screening methods like elementary effects or meta-modeling, to simplify traffic simulation models. So sensitivity analysis in particular allowed us to identify the non-influential parameters and therefore to limit the calibration efforts only to those parameters that mostly affect the simulation outputs. And we did this on different models. We applied to microscopic models like MidSim Lab, developed at the MIT, and to commercial software, IMSUN and BISSIM, one mesoscopic model, another macroscopic model developed at the French Institute Ispra. And this was so simplifying models was particularly beneficial for microsimulating big networks, and we had an experience in particular in the simulation of the metropolitan area of Zurich in Switzerland. Then also we applied variance-based sensitivity analysis techniques to the, let's say, the bricks of traffic simulation that are the car following models. And in doing this, we were able to improve the basic knowledge on such models. Another major achievement has been, for sure, the development of a simulation platform that aims at providing a common evaluation and benchmarking framework for origin, destination, estimation, and prediction algorithms. Again, this allows to fill a gap in the field literature where the evaluation of different algorithms was never possible so far, because, as in the case of my previous paper, all these studies are based on different settings, using different models with different data, and so we think this is a really important contribution to the field. And the framework is implemented in MATLAB and Python and uses the Imsun traffic simulator for the traffic assignment.
Mm-hmm. Oh, sorry.
No, just to mention another couple
Yeah, sure.
of results.
Sure.
Yes, because we worked a lot also on data, of course,
Mm-hmm.
and we developed a methodology to reconstruct trajectory data from noisy measurements and applied to one of the data sets from the US project NGC. And I'm proud to say that we will post this data soon on the Action website. And finally, let me only mention two of the main deliverables of the Action. A book impressed by Taylor and Francis that provides a comprehensive overview of calibration and validation techniques for traffic simulation models that has been edited by Winnie Diamond, Christine Buisson, and Serge Hogenler, and the Case for Guidelines that review the context of this area and suggest a roadmap for future developments, so forging a link between academics and practitioners. This has been edited by Mark Braxton, Peter Vortisch, and by me. So I think that it's a long story, but these are really the main outcomes of the Action.
But very interesting. How this has been disseminating? For example, I think you are trying to get a special issue at the transactions on intelligent transportation systems.
Yes, sure. We have organized this issue that is expected to provide the main outcome of scientific outcome of the Action. Of course, it is open to not only to multiple participants but to the whole community. Mm-hmm. And we also promoted a number of special sessions at world conferences, like, for example, given the IEEE ITS conference, mm-hmm. and the TRB. And but also we organized the 3 summer school, and let me say that they were very successful. We had on average 40 attendants. Good. from coast countries, but also from outside Europe, say from Brazil, Iran, Kenya.
Really?
And yes, really. And it's a really long trip from Brazil, for example. Yeah. And we tried to get the attendants acquainted with these techniques for the management of uncertainty, mm-hmm. and it was also very challenging to have hands-on sessions that guided them to really the application of this process of uncertainty management in traffic.
Very well. Congratulations on that.
Thank you.
Well, we need now to make a short break, but we're back in just a few seconds, so please don't go anywhere. Hi again. Thanks for listening ITS Podcast. Do you use LinkedIn? Do you know that we have created a group for this publication? Why don't you join us there? Just search for ITS Podcast and join us. Remember, ITS Podcast. And if you want to receive an email every time a new podcast is launched, please click on the follow button on the right side of our website at itspcicei.com. You can introduce your email address there, and you can be the first to listen to our next edition. Now let's get back to Professor Punzo. Hello, we are here again talking about simulation and modeling with our today's guest, Professor Vincenzo Punzo. Professor, these cost actions usually end up with wrapping up final event. In your case, I think you'll have a final conference for that. Could you explain what is the aim of that final conference?
Yes, sure. First, please let me advertise the conference. It will be held in Naples.
Sure.
On the 4th to the 6th of December this year in 2013. So please contact me if you are interested in joining the conference.
I think it's a funny place to have a conference on traffic simulation in Naples, right?
Yes, we do not have so good fame. Yes.
Okay.
So in the objectives you asked me. Well, the objectives of the final conference are, of course, to disseminate the scientific outcomes of the action, and to foster the discussion and scientific investigation on these topics, on the topic of management of uncertainty in traffic simulation. If I could say something more, we will debate the impact of uncertainty in traffic simulation on the transportation engineering practice and on the transportation decision-making process. In particular, we will have a roundtable in the first day with eminent participants from the academia, the consultancy world, and also the client worlds. So we will have also 3 keynote speeches and a number of invited presentations that will cover many theoretical and practical aspects, including also calibration, validation, sensitivity analysis in traffic simulation, but also in pedestrian and in traffic control.
Very interesting.
So,
okay, and regarding this project, what are its future plans? Do you plan to extend the networking you've been coordinating beyond this project lifespan?
Yes, really, we would like to maintain the heritage of multitude. It's not easy, of course, and to this aim, we are going to apply for another cost action, and it will deal with this time, hopefully, with uncertainty in mobility demand. And we are also looking for funds to continue our work and produce international traffic simulation guidelines. So these are 2 basic, ways.
Good. And speaking in a more general fashion, could you tell our audience what are the current and future trends in simulation and modeling? There has been lots of research on these topics, so we want to know what you think will be hot soon. For example, you or your colleagues are working on new models including, I don't know, greenhouse gases emissions or B2V, B2I, or B2D communications, these coordination and communication architectures. I don't know, what do you think will be hot in your area now?
Nice question. Well, let me say that the general trend, my opinion, can be envisaged in the integration of different simulation tools and environments. You was just mentioning the example of greenhouse gas emissions and B2B and B2I communication. I think that here the challenge is not, let me say, not only in the fidelity and in the accuracy of the individual models, but just in their coupling. Because these models initially were not developed with the same, with these objectives. If I can give you an example, driving cycles provided by traffic microsimulation models as the results of elementary differential equation are really far away from the real-world driving cycles on which emissions models are based. And also, I had a nice experience this year in a project, an European project, where we found really many difficulties in mapping the heterogeneity of real car performances into the parameters of car and traffic simulation models. And of course, this is necessary for a comprehensive emission calculation. And I do not know if it's the right direction. So I think that more detailed vehicle modeling will be introduced, for example, in traffic simulation, even at a network scale. And of course, this is not achievable now with the current computing capabilities, but will be possible in some years. And also regarding ITS, I could say that unfortunately our model are showing some limitation in simulating the impact of the ITS. And this is because many ITS applications affect some aspects of the human behavior that are not explicitly modeled by the current models. And so I think that research in modeling will focus on these behavioral aspects and also putting the man in the loop of the simulation as actually is in driving simulation, for example. And also, of course, taking advantage of the huge amount of new data available.
Mm-hmm.
And I think this is also the concept behind cyber physical systems, but this is really beyond my imagination and current knowledge. So I would like to stop here.
Very interesting. Okay, Professor, thank you very much. Very interesting indeed. I think this is all. I'm very sure that our listeners will enjoy your interview. So goodbye, Professor. Thanks again.
Thank you again, and goodbye to everybody.
Goodbye, thanks.
Goodbye.
That was all for now. We are eager for reading your comments on this and all the other episodes. Tell us how can we improve it. This podcast is sponsored by the IEEE Intelligent Transportation Systems Society, website designed and managed by the Innovation Center for the Information Society at the University of Las Palmas de Gran Canaria in Spain, soundtrack developed by Rubicon, language advisory by Manuel Arbelo. We'll be back soon bringing you again the cutting edge of science at the Intelligent Transportation Systems podcast. Thanks for listening and drive safe.